Hi, Scott here. So in this video, I want to go over HinksPix slash EasyLights integration in xLights and show off some of the features that xLights has and how to use them with a physical controller. First thing I want to say is I don't have any official affiliation with Holiday Coro or anything. All this integration I did myself. I actually physically bought a controller and then I went through and reverse engineered like their web page and their file protocols to add all this integration. If you have any issues with xLights and integration with the EasyLights or HinksPix controllers, please contact me. I'll leave my contact information in the video description and I will try to help you as much as I can to get it working. So I started working on this about December of last year. Uh, right around Christmas time, I got the controller and I started figuring all this out. So since then, I've kind of added some different capabilities to xLights. It has the basic controller upload capability, similar to like the Falcon and the SanDevice controllers, where we can upload the input configuration and the output configurations for the pixels and the DMX ports. And then it also has, I added after the season last year, the ability to generate files for the standalone mode. It supports the HinksPix Pro controller right now. That's the 48 output controller with the different, with the standard 16 port local output card and the long range differential. And then it also supports the EasyLight 16 controller, which now is also called the HinksPix 16, which is another older controller. So things that currently aren't supported, I'm hoping to add in the future. There's no integration for the newer smart receivers that Joe has been coming out with, and it also does not support the HinksPix Pro with the AC output board. I have some ideas on how to implement this stuff, so that may be in there in the future, but I'm not making any promises at this point. So let's first just go over how to add a HinksPix Pro controller to xLights, and we'll show how to do like the basic configuration of it. So in xLights, we have the controller tab here, and when you want to add a HinksPix controller, you need to add an Ethernet. So we'll click that, and the first thing you need to do is put in the address. I'll bring over my web page here. This is my HinksPix Pro controller I have on my network. It has an IP address of 192.168.1.7. Right now in the controller, I have a long range differential board in the first output, and then I have the local 16 port SPI in the second output, and I have nothing on the third. So when we configure this in xLights, this is something you got to kind of remember. So if we want to put something on the local ports, it has to be ports 17 through 32, and if we want to put something on the long range receivers, those are 1 through 16. Just close that for now. In xLights, we added this Ethernet here. The first setting is the name of the controller. This is kind of just a key for the user to know what this is. So we can just call this our HinksPix Pro. And you could put location or something if you wanted to, like Megatree but we'll just keep it as HinksPix Pro. There's also a description field, so you can even put more. You could say it's your Megatree left controller, but just leave it blank. And kind of the critical thing here is these vendor drop down. We'll select HinksPix, and then the model is the Pro. And once we select that, it'll add an option to do auto layout models. And this is in the newer xLights, the 2020.6 and newer. This allows us to like kind of configure the controller easily with the drag and drop visualizer. I want to enable that. And then there's also an option to auto size, which will automatically increment the number of universes on the controller. So I also want to enable that as well. We need to put the controller IP in here, which I said was 192.168.1.7. And I just hit tab to put that in there. And we'll leave the protocol at E131. The HinksPix controllers actually support E131, ArtNet, and DDP. All of those are integrated in xLights and should work, but we'll just keep it at E131 for now. And we'll just keep everything else. We'll have it start at Universe 1 for now, and we'll just hit save. And hopefully we should be able to hit the open button here. And it opened up our controller. Everything looks good. That's the basics for just setting up a controller. But then from here, if we want to use this in our layout, let's add some models and configure it for the controller. Let's do the most basic thing first. Let's just do a mega tree. We'll do a 180 tree here. So 180. We'll do 16 strings, so that's the number of physical ports on the controller. And then we'll do 50 pixels up, so basically there'll be 16 strings of lights, 50 pixels long. So we'll just do the default. Well, that's pretty standard. Let's add a star at the top. Let's do like a 3-layer star, so we'll have 90. And then we can do layers by doing 20, 30, 40. And this will basically make 3 layers of 20, 30, 40. Let's put that on the top of our tree. And then let's just do some other props. Throw some arches in here. And then let's do like a polyline for our roof line here. With a polyline, hit the escape at the end to finish it. And let's say our roof line, let's just put a number in here of 250. And we'll just call that as a good starting point. We got some models here. And then now you can come in here and configure these manually for the controller, but kind of the newer way to do stuff in the 2020 version of xLights is there's this visualize option in the controller tab that lets you just drag and drop your models onto the physical controller port. So let's do that. Let's do the visualizer here. So in the visualizer, it shows you your ports on the controller and then all the models you have. So as I kind of showed earlier, the local ports actually start at 17. So let's put our mega tree on that. So if we put our mega tree on 17, as you can see here, we had a 16 by 50 mega tree, so it put on port 1. Or on port 17, it put the first string of it, and then it went all the way to 32. And then for this other stuff, and let's say our star, we want to put that on port 32, but we want it after the mega tree. So we're going to have our mega tree go up and down, and then we'll just have this at the end. So we'll put that at the end there. And then the other stuff, let's just say these are on receiver boards. So we're going to put them on our differential receiver. We'll just chain the arches after each other. We'll say that's one receiver board. And then we'll say our house polyline is another receiver board. So the first 4 ports is the first receiver board. And then we'll do 5 through 8 as the second receiver board. So that's just a basic configuration I have here. So once you're done, this will automatically just saves as you go. So you should be able to just close it. And if you can kind of see what it did here, the reason why this save button is illuminated is as we were dragging them, it actually added more universes to the controller for all those props. So basically based on the number of props we dragged onto that controller, xLights automatically increased the size of the controller. And that's why there's the save button, is you need to save that now it's got more universes. It only had 1 originally, now it's up to 8. And if you look down here, it'll show you all the models that are also on the controller. Now that we have that set up, you can go into here, you can go back to the layout tab and you can actually see all the controller connections will display in this column as well. And we can also go in here and change settings if we want. So the upload for the HinksPix supports all of these settings. If they're not checked by default, it just won't set them, and it'll keep the controller default. But like if we wanted to go in and set the mega tree to be 50%, and we wanted the star to be 50%, we could add those settings right here, and then when we upload to the controller, it would configure the controller with those settings. Now that we got everything we like, we'll just upload to the controller. We have to upload the inputs, which basically will tell the controller which E131 universes to listen to. And then when you upload the outputs, that'll upload the model configurations, so what pixels are on what port. Let's do the inputs first. So we just click the upload inputs. Once it's complete, you should see this HinksPix upload complete here. And if you see anything that says like failed, that means it didn't work. You may have your IP address wrong, or you may also want to check the version of the firmware of the controller. I'm currently running like version 74 of the main firmware. I have helped some people before. They've had like version 50 and xLights didn't work with that. So you need to make sure it's at least probably in the 70s. But if we go to our E131 page here, you should see xLights uploaded those 8 universes. So when I hit the upload inputs, it uploaded universes 1 through 8 and kind of set them up for us. If you look here, the channels per universe is 510, and it put all that information in for us. Okay. So now that we have the inputs uploaded, now we need to do the outputs, and this will basically, as I said, put the output configurations of the pixels into the controller. Just click Upload Outputs. Okay, once we did the upload outputs, it'll come down here in the corner and say Upload Outputs Complete. And then if we hit Open again over here, it'll open the controller back up. After it does this, it actually reboots the controller, so it might take a second here for the controller to come back up. But first, let's go to the long-range differential ports. So these are the long-range differentials. If we compare this to like our Visualize tab, on port 1, xLights put 100 pixels, so that's our 2 arches. And then on port 5, it put the 250 pixels, which is our polyline. That's the differential output, that's the first 16. If we go to the second one here, the SPI, this will be the local 16 ports. And if we scroll down here, this should be our mega tree. So you'll see the 50 of the first 16, which match. And then at the very end, it should be 140 because of the star. So the 50 of the mega tree plus 90 of the star, we got 140. And you can also tell it put the brightness of 50 that we also imported in the other tab. If you hover over this, it'll say brightness of 50 at the bottom there. It also put the brightness of 50 in the controller. To me, it looks like everything kind of uploaded as it should. Now you can use this controller as a E131 output and drive your lights from like xLights or FPP. There is kind of the second thing with the HinksPix controllers is they also support a standalone running mode. You can actually upload files to an SD card and put them in the controller, and then you can just run the controller by itself. Here's kind of a picture of my controller. If you can see, there's this SD card reader that you just put it in. And with the HinksPix Pro, there's also a audio output jack. So you could plug this into your FM receiver, and if you have sequences with music, this would play the sequence like on your tree and play the audio through the audio output. In xLights, there's a dialog to do all this stuff. Let's just close this and we'll go to Tools. Under Tools here, there's the HinksPix Export. And so this dialog is what you would use to create these files. Let's just talk about the files a little bit here first. So the HinksPix needs, if you're just going to do a sequence that has no music, it needs what's called an HSEQ file. This is similar to an FSEQ, but it's got a little different header information for the HinksPix controller. If you're playing an audio song, it requires a AU file, which is similar to a WAV file, but it's got a little extra information. And then there's also a schedule and a playlist file. These are all kind of generated by the export dialog based on the settings you put in here. Basically, all you would do is you would select the controller, you'd select the mode that you want the controller in, and then where your SD card is. We have our HinksPix controller here. If we want to create the files for it, we check it. And then this should populate. If you set this up as a HinksPix in here, it should know that this is a HinksPix and populate this list. The mode. So the HinksPix controllers can work in a couple different ways. So I made a little diagram to try to describe it. Similar to like FPP and others, you can do like a master and a remote style integration. So you can have like your master controller that you put sequences on, and it'll play. And then you can also have a second HinksPix or an xLights controller and also put an SD card in it. And these can sync over Wi-Fi or Ethernet with a packet, and they'll sync to the music. So they would both have a separate SD card, but then they would keep in time with each other and play the sequence. That is all supported in xLights. I won't show that in this video. But then there's also this way to drive what Joe kind of refers to as foreign slaves or slave controllers. You can also plug in another E131 controller that's not part of the HinksPix ecosystem, and you can drive that over Ethernet. In the dialog, there's an option for the slave 1, slave 2. So the capability is the HinksPix can only drive approximately about 50 universes worth of data on one of these slave controllers. So if you're using one, it can do about 50. If you're driving two, because you can actually drive two with the HinksPix Pro, it can only do 50 total. So you have to keep it about 30, 32 on one and about 16 on the other is kind of the max. But if you were to set up in xLights here, let's say we want to add a second controller, and we'll just put, I have a Falcon plugged in as well, so we'll put the IP of the Falcon I have on my network. And we'll put the vendor as Falcon F16V2 here. And we'll just hit save on that. And then when we open the HinksPix Pro or the HinksPix export dialog again, we'll see now that this slave, we can select the controller. So the Falcon, I didn't change the name from the default, so it's just called Ethernet. If you enable this, now when I generate the files for the HinksPix, it'll also include the E131 data for that Falcon, and it'll send that data to that slave controller. So your HinksPix will basically be the master, and it'll send lighting data to the slave, to the Falcon as its quote-unquote slave controller. That's kind of the more advanced things you can do with it. I'm just not going to do that. I'll just do the kind of the default here. And this setup is basically you have a single controller and it's just files locally for that controller. This mode select dialog kind of says if it's the master or remote controller, or there's an option to don't set. When you set it as the master, this will actually generate a file on the SD card, and once you plug the SD card into the controller, it'll automatically put the controller in master mode. If you put it to don't set, it won't generate that file, and the controller will stay in whatever its previous mode is when you boot it up. So like if the controller is currently like an E131 mode, it won't change it to standalone master mode when you put the SD card in. It's kind of good, I think, to put it in master, because then once you put the SD card in, it'll automatically switch it over to master. So this is the drop down of all the drives on your computer. So my SD card is the F drive. I checked create to create the files, and then the list below here is all the sequences on your computer. I kind of just made some generic sequences that probably won't work with this controller because I haven't re-rendered. But just to show kind of how this works, you check the sequences you want to put on the SD card, and then that will be the HSCQ files will be created from these and then put on the SD card. But there's these up and down buttons on the left here to adjust the sequence order. All of them that are checked, it'll make a playlist out of, and then it'll play them in the order of this list. So if you want, like, let's say this butterfly sequence first, you'd use the up arrow to put it higher in the list. And if you wanted Jingle Bell Trap here to be next, you'd put that second. Or if you wanted bars to be next, you could move that up. So that's what the point of these buttons are. This is what affects the order of your playlist when you put it on the controller. As you can see here, the first two are just FSCQs. So these are just like sequences, animations. And the second file here has a MP3 file, and xLights will convert this to a WAV and then convert this to a AU file used by the HinksPix controllers. And then kind of lastly here at the bottom, there's a little, this start time, end time dialog. This sets the schedule of your show. In xLights, it's very limited to, you can only set one time for every day. If you wanted this to start, if you wanted your show to start at like 5 o'clock every day, you could just set this to 17, it's military time, to whenever you want your end time to be. If you just set it to 00:23:59, basically it'll play all the time in a loop. Or you can set this to a time, say you want to go from 5 to 10. You could set this, and it would basically make a schedule to play your show from 5 to 10 every night. As part of this, you'd have to go into your controller and make sure you set up the real-time clock correctly and the time in the controller so it'll play at the correct times. But let's just keep it at 0 to 23:59. So with this, it'll basically play all the time. And once you kind of have everything set up how you would like it, you can just hit export to SD card, and it should generate all the files here. So once it's kind of done with everything, you'll get this box saying it's done. And the reason it kind of does that is if you had multiple controllers, you could then uncheck that one, check the next controller, swap out the SD cards, and then just use the same SD reader, hit export again, generate the second controller, and kind of so on and so forth. So you don't need multiple SD card readers. You can just use one, kind of check it, generate it, check the next one. Let's kind of look at what it actually did here. As I was kind of showing in the document there, it makes these HSEQ files. So these are the physical sequences. The names may be a little different than what they are in xLights. I kind of, as I said, I reverse engineered this from Joe's stuff, and he always used uppercase, so I kind of did the same thing. And I also removed like spaces because I don't know how that'll work on his controller. The first two there, these are just those animations. And then like Jingle Bell, this is the Jingle Bell sequence, and then the AU file is the audio sequence. So this will basically play back audio on the SD card. And then all the other files in here are related to like the schedule and your playlist. As I kind of said, the order in here, it'll generate this playlist file. And if you actually open this up, it's a JSON file, if you know what that is. And it'll basically have the order of your sequences. So Butterfly was first, then Jingle Bell, then the bars test. So this will be the order it plays back. And then these schedule files, this is when it'll play, the times it'll play. So since we just did 000, it'll basically play all the time, and then I'll tell you which playlist to play at that time, which is main because we only have one. And this file is what sets it to basically be into master mode. So if you didn't want it to automatically go into master mode, you could just delete this file. That's kind of the basics of the SD card. At this point, you would just take this SD card, put it in your controller, and if you reboot it, it should just start playing. I don't have a good way of showing that because the web GUI doesn't actually show you anything, but that's kind of the basics of it. If you have any questions or need any help, just feel free to contact me. I'm on Facebook as Scott Hansen. I'll put my email in the description, and thanks.